Quantum mechanics is a branch of physics that deals with the behavior of matter and energy at the smallest scales, including the behavior of atoms, molecules, and subatomic particles. It was developed in the early 20th century and has since revolutionized our understanding of the atomic and subatomic world. Hello viewer, welcome to another video. In this video, we will explore the development of quantum mechanics and its implications for various fields. The development of quantum mechanics. Max Planck's proposal of the quantization of energy. The foundations of quantum mechanics were laid by German physicist Max Planck, who proposed the idea of the quantization of energy in 1900. The foundations of quantum mechanics. The foundations of quantum mechanics were laid by German physicist Max Planck in 1900. Planck proposed the idea of quantization of energy, which stated that energy could only be absorbed or emitted in discrete amounts. This was a major departure from the classical physics of the time, which believed that energy could be absorbed or emitted in any amount. In 1905, Albert Einstein published a paper on the photoelectric effect, which provided empirical evidence for the quantization of energy. The photoelectric effect showed that electrons could only be emitted from a metal surface when a certain amount of energy was absorbed. This provided a concrete example of quantization and helped to solidify the idea of quantization as a fundamental principle of nature. In 1913, Danish physicist Niels Bohr proposed his theory of atomic structure, which incorporated the principles of quantization. Bohr's theory explained the behavior of electrons in atoms and provided a framework for understanding the behavior of atoms in terms of quantum mechanics. Wave-particle duality and matrix mechanics. In the 1920s and 1930s, a number of key developments took place in the field of quantum mechanics, including the formulation of wave-particle duality by Louis de Broglie and the creation of matrix mechanics by Werner Heisenberg and Max Born. Wave-particle duality is a fundamental principle of quantum mechanics that states that particles, such as electrons, can exhibit both wave-like and particle-like behavior. This principle was first proposed by Louis de Broglie in 1924 and has since been confirmed by numerous experiments. Matrix mechanics, on the other hand, was developed by Werner Heisenberg and Max Born in the early 1920s. Matrix mechanics is a formulation of quantum mechanics that uses mathematical matrices to describe the behavior of particles. This formulation provided a different, but equivalent, way of describing quantum mechanics, and has since become one of the most widely used formulations of quantum mechanics. Schrödinger's wave equation. In 1926, Erwin Schrödinger formulated his wave equation, which provided a different, but equivalent, way of describing quantum mechanics. Schrödinger's wave equation is a partial differential equation that describes the behavior of quantum systems in terms of wave functions. The wave functions are mathematical representations of the quantum states of a system, and the wave equation provides a way of determining the probabilities of the different quantum states. Revolutionizing our understanding of the atomic and subatomic world. The development of quantum mechanics has revolutionized our understanding of the atomic and subatomic worlds. It has provided a framework for understanding the behavior of atoms, molecules, and subatomic particles, and has had far-reaching implications in fields such as chemistry, materials science, and electronics. In chemistry, quantum mechanics has provided a way of understanding chemical reactions and bonding and has led to the development of new drugs and materials. In materials science, quantum mechanics has been used to understand the behavior of materials at the atomic scale and has led to the development of new materials with improved properties. On the other hand, in electronics, quantum mechanics has been used to understand the behavior of electrons in materials and has led to the development of new technologies, such as transistors and semiconductors. Furthermore, quantum mechanics has also led to new fields of research, such as quantum computing and quantum cryptography. In quantum computing, quantum mechanics is used to developing computers that can solve complex problems much faster than classical computers. In quantum cryptography, quantum mechanics is used to securing communication through the use of quantum states of particles. Despite its many successes, quantum mechanics remains one of the most actively researched areas of physics. There are still many questions that remain unanswered, and new discoveries are being made all the time. Please follow us on social, and don't forget to like and subscribe to our YouTube channel. See you soon.